It's a kind of a very challenging idea. He insists that his idea is, everybody said that design is a very hard process. It's a very abstract process, complex process. And is it also very, very hard to teach how to design? Design can be only educated through experience, and it takes time or something like that. So he thought that that's not true. There must be some other systematic way, and he invented this kind of theory. The key point is, as a mathematics, design has also axioms. If you satisfy or follow the axiom, then you will end up with good design. That's the bottom line of all this axiomatic design. The name of axiomatic design comes from because there is a design axiom. And think of the mathematics axiom, the most important and unbreakable rule. And based on this axiom, there could be many theorems. And based on the theorem, there could be many lemma. So we are talking about the most important rules in this design. Okay. According to the Namsu's paper, there is you can also find many design theorem. Everything is based on these two axioms. First axiom is independence. Second axiom is amount of the information. Let me briefly introduce all the process. In axiomatic design, they divided the design space into 4 categories. One is customer needs. Second is functional requirement. Third one is design parameters. Fourth one is process variables. And they are kind of interrelated to each other, step by step. Customer needs is, as the name says, the list of what the customer needs about the design. You can specify one customer need one by one, like that. Okay? Think of the QFD process. On the left column, you had customer needs or customer requirement. Okay? If you see every 4 categories at the same time, it is very complex. But just focus on 2 by 2. So first step is focus on customer need and functional requirement only, without this design parameter and process variable. If you only look into the customer need and functional requirement, all you have to do is list up the customer needs, which is what part, what the customer needs. List them up in customer's own language. And functional requirement is how part. How we can satisfy this customer needs by providing this kind of function of a product. So you can list up the functions here. So if you only look into these two, this is what and this is how. Okay? For example, let's say a cup design for the QFD example. It was look like that. There was some insulation pad and very large handles. We know who is the customer and the customer needs. Holds a lot, keep warm, looks good, stable, or something like that. These are what the customer needs. How? It's a functional requirement. You can rewrite the customer need into functions of the product. function should be able to, and according to this axiomatic design, this is a functional requirement and it should be stated as a verb. 동사, verb. Holds a lot of liquids. Keep things warm, very long time. And the like. It's a functional requirement. Okay. Let's assume these two parts and their relationships are identified. The next step is to focus on these two only. 2 by 2. Now if you look into these two, now this is what part? What is your functional functions? The required function of your product. That's a what part now. And this is how part now. How? First one was holds a lot of liquid. Okay? And the design parameter means the characteristic, or as it said, design parameter. Something that can describe your product. Like volume, bottom area, height, something like that. Holds a lot, has some meaning, relationship with volume. Holds a lot is related bottom area. Holds a lot related height. Holds a lot doesn't have any meaning with the insulation material or something like that. Okay? For now, this is what part, it's a how part. How are you going to satisfy the functions? By making this parameter of a product. Okay? Now this part. Design parameter and process variable. Here you have design parameter like volume, height, weight, insulation material, thickness, handle size, something like that. Process variable is, or now it becomes what, and now it becomes how. Okay? You have this description of, design at these stages. How are you going to make it? Well, I don't know. By cutting a large sheet of paper, sheet of aluminum steel and wrap it up and make this shape. Those kind of, how are you going to make this part? What? Okay? Can you see the relationship? If you only choose 2 out of these 4 category, left one is always what? Right one is always how. Okay? But usually, many people tend to focus on this relationship because this is most important and most complex part. For example, it has relationship like this. According to axiomatic design, you are supposed to make, there is functional requirement 1, 2, matrix. Can you see? So for example, if you have n number of functional requirements, you are supposed to have exactly same number of design parameters. This is the most important difference from QFD. Okay? The number of design parameters should match the number of functional requirements. And if design parameter satisfies or related, or in axiomatic design term, coupled with design parameter 1, you can check 1 or check mark or something like that. Or A11, because if you need some more description, why FR1 can be satisfied DP1 or something like that. And according to this axiom number 1, good design should be an uncoupled design. Uncoupled, I mean, is things are uncoupled in this matrix. For example, if you have 5 FR, 5 DP, and you will have this 5 by 5 matrix, and assume that all the element, 25 element is not 0, which means they have some relationship with each other, then it is totally coupled design. Which means if you want to change something, for example, I'd like to put more focus on functional requirement number 2, then you have to think about DP 1, 2, 3, 4, 5, because everything is coupled. Once again, if you change DP 1, 2, 3, 4, 5, it will re-affect functional 1, 2, 3, 4, 5, because everything is coupled together, which is bad. And most important, and I mean very straightforward example is the faucet design. Okay? Let's assume that we have hot water, cold water, and there is a one faucet. What's the functional requirement of the faucet? 수도꼭지. You want to control the volume, you want to control the temperature. This is a volume control, this is temperature control. Okay? And let's think about this conventional faucet. You have a dial on the hot water side, the dial on the cold water side, and this comes to, right? Let's say this is design 1. Conventional. Design 2. Let's assume some advanced design. There is a stick. If you move the stick this way, then only volume changes. If you move the stick this way, only temperature changes. Okay? That's the new design. For the conventional design, you have 2 design parameters. Hot dial, cold dial. Let's assume DP1 is a hot dial, DP2 is a cold dial. Volume control, related, right? Temperature control, also related. Coupled design. So it is possible to increase the temperature with the same volume. Okay, you have to turn more on the hot side, but at the same time you have to reduce the amount of the cold water at the same time. According to this design theorem, it is bad, too complex. Okay, but in new design, it's uncoupled. You can easily change without affecting each other. So that's the bottom line of independence. Independence between design parameter or diagonal matrix or upper triangle matrix or lower triangle matrix is kind of uncoupled design, which is good design. Okay? And second theorem is amount of information. I think, I don't know exact name of those kind of thing, but there is sometimes some silly contest is going on. Like for example, how can you push a toaster button in some, you can easily find a YouTube video, like the most simple and good way is that you just push the button of the toaster, but in some contest, if you push the button, some balls drops and it hits another spoon and it will ring the bell and it will start the RC car and the RC car jump into the basket, so it will move your leverage, and leverage will also initiate something else and blah 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 and hit the button. Okay, you know this kind of mechanism. We do this kind of thing for fun. So compare to this one and simply push the button. Simpler is best. Okay, so no argue about it. So axiom number 2 is like that. If you can satisfy your functional requirement in various ways, simplest possible one is the best one. The most the best alternative is the alternative which has the least amount of information. Okay, all this complex system has many information, which is bad. The simpler, least amount of information is better design. So these two are the axiomatic design. Okay, so let me. You can understand all of this detail by reading the paper written by Nam-Su, who is the inventor of the axiomatic design. And this is one example I did for the mobile harbor team. My job is to conceptually design a robotic arm docking system. And we know the customer, and we are at this stage, we are not interested in the parameter, process variable. So I started from the top level, because this is also design process. Your FR are structured like tree, your DP are also structured like tree. So this is the top level FR DP of a mobile harbor system. What's the functional requirement of a mobile harbor? Well, it should be able to transfer container from and to ships anchoring in the sea to a harbor. That's the bottom line. And design parameter to satisfy those functional requirement is mobile harbor system. Okay? Okay, good. How we can divide this top level functional requirement into more detail? Like this. We identified 5 subcategory, sub-functional requirement. First one, mobile harbor, DP, mobile harbor should be able to load, unload the container, and it also should be able to keep the containers in the mobile harbor. It should float, it should navigate, it should moor to the container ship. That's the basic functional requirement. As I mentioned, mobile harbor verb something, it is kind of iterative process going down into the more detail. And the design parameter which will satisfy load, unload the container is, in our design, it's a crane system. Crane system will satisfy the functional requirement number 1. And also, as you can see, the sub-functional requirement will be a part of the top level. Same thing happens. Design parameters are also subsystems of the mobile harbor. So deck system and loading method will satisfy FR number 2. And my job is focusing on this docking and mooring system, DP number 5. So for top level FLDP, I analyzed this design. Sorry, almost everything is in written Korean. So don't have to think about the diagonal term, because it is selected to do something with this thing. DP1 is conceptually developed to satisfy FR1, so no need to reconsider it, the diagonal term. But anyway, for example, A12, which means DP relationship with DP2 to functional requirement 1. Okay? And I write them some description. It will be best if there is nothing except the diagonal term, but in reality, this kind of thing is really, really difficult. But I tried my best to uncouple it. But this is a kind of semi-coupled design. Okay? Another example. So I only choose the functional requirement number 5 and DP number 5. Moor to the container ship and docking and mooring system. And FR5 has also the sub-functional requirement FR5 1, 5 2, 5 3, and 5 4, like this. And it has, in order to satisfy this FR5 1, which can be translated as should be able to move mobile harbor to designated docking position or move away from the docking position. So in order to satisfy that one, finding out the most probable design parameter is azimuth thruster system and bow thruster system. That's my choice among many alternatives. I use the team discussion, AHP, and other things in choosing this DP51 here. Okay? And choosing this appropriate DP is actually design process. Okay? And this is the kind of conceptual drawing of what we thought, robotic arm and other things. And also did some kind of coupling analysis. So it looks a little bit better than the previous matrix, and have to pick one by one. The most important thing was in my opinion, is FR53, which can be translated into the mobile harbor system that should be able to keep the relative position from ship and mobile harbor. That's the FR53. And it can be decomposed into the more detailed FRs. And the choice of my design parameter is robotic arm automatic mooring system. And it has also the sub design parameters. So if you do that again and again, so your numbering will increase 5, 3, 5, and the like. You will go more deeper in and deeper conceptual design. It is a kind of the original conceptual drawing of selection of the vacuum suction pad. And by collectively putting all those design parameters together, we just followed this, ended up with this kind of robotic arm system. It's just conceptual sketch. And another alternative was the utilization of some electromagnetics, but it is not chosen because of due to some analysis comparison. And actually the sloped cable arrangement, those kind of thing could be also your design parameter. Also the number should be even. This is also a design parameter and should be arranged in mirrored way. That's also design parameter. So this is the actual arrangement of our robotic arm system. This is nicely done, uncoupled, sorry. And by following this axiomatic design step, we are able to assign the location and number of fenders and size. and other things. And it is actually the whiteboard we used to the design. That's how this axiomatic design is applied to the development of this automatic mooring system of mobile harbor. If you are to develop a very brand new system, I think I strongly recommend to utilize one of these axiomatic design principles. No argue about it. Okay? Okay. Any question? This is the last class before this Korean Thanksgiving holidays. So, are you happy? Okay. Even though it's a very long holiday, please keep in touch with each other. You need to make a progress in team project number 1. Okay? Question? Comments? Okay. Thank you, guys.